So in this problem, we are tasked with creating an inequality. We are actually told specifically that we are going to create an inequality, and we're asked to represent the situation when the monthly cost for store S is less than the cost for store T. All right, so I'm going to start out just with that very, very simple framework. So I want S, this store, to be less than T. All right, now I've got my information for both S and T, and now I've got to create some expressions for each of these to fill in. All right, so what do we know about S? Well, S is $2.50 per game with a $5 monthly fee. All right, so it tells us to use the variable V for the number of games. So for S, my expression would be 2.5 V, because it's $2.50 per game, plus there's a one-time monthly fee of $5. Okay, so that's my expression for S. I'm going to go ahead and keep my inequality sign. And then T is just the expression would just very simply be $5 per game. And that's it. That's all we need to do here. So for this problem, we are asked to create an equation, and we know it's an equation because it tells us specifically that we want to find when these companies would charge the same to paint a room. All right, so we're given the rates for the best painters company at $100 per room, $15 per can, and then top painters at $75 per room and $300 per can. So because it's a single room, we don't need to have a value for the per room. We don't have a variable for the per room because it's just going to be a single room. Per can, though, we're going to use the variable P, which is what we're given in the problem. All right, so very simply, we want to create an equation where best painters would equal top painters. So now we just need to come up with our expression for best painters and then our expression for top painters. So for best painters, we've got $100 for the room. We're not going to multiply that by anything because we're just doing a single room. We're just doing one room. And then $15 per can, so that's 15p. So this is our expression for BP. And then for top painters, we've got $75 for the room, and then $30 per can, which we're going to represent with P. And that's it. That's our equation. So for this last question in this problem set, we are again asked to create an equation. And we know it's going to be an equation. We know the two sides are going to be equal because it asks us to come up with a situation where, what are the two gentlemen now? Araceli and Hugo spend the same amount of money. All right. So this is the information we're given. Araceli, I hope I'm pronouncing that correctly, rode 30 rides and then spent $15 in games. And then Hugo did 25 rides and then $20 in snacks. So this $15 and this $20 is just a flat number. It's just a total number. So we're going to treat those as constants. The rides, we're not actually sure how much each ride costs, so we're going to use R as the value, the unknown value for the rides. All right, so we want a situation where A is equal to H. So now it's just a matter of we need to create an expression for A. So he rode 30 rides, so we're just going to do 30. We don't know how much the rides were, so we're just going to use R as our variable, plus the $15 for A. And then H, he rode 25 rides. Again, we don't know how much the rides were, so we're going to use R to represent the cost per ride, and then $20 in snacks. And that's it.